Part 2 of the DIY LED desk lamp kit. And you're looking at the resistor, and there are two kinds of resistors. One's 200 ohms, one's 10,000 ohms. I recommend you check them with a meter. If you don't have a meter, you can go by reading the stripes. Red is 2. There's a red stripe on both of them, but the red stripe is on the end of the 200 ohm resistor. Now I'm looking at the diode. There are two diodes, they're identical, and I showed you the dark end. The stripe at the dark end is the cathode, the negative end, and you can see the stripe on the board, 1N4148, and the stripe on the board goes with the dark end. So that's the polarity of the diode, and if you put those in the wrong direction, it won't work. So now I'm going to solder. So you're looking at the tablet on the left, and you're looking at me soldering on the right. And I'm not using the microscope with the tablet to solder. I'm just using that so you could see better. I'm actually using that circular magnifying lamp that you see in the upper right-hand corner. I'm using a knife edge tip on my soldering iron. I like these because they get hot real quick, and you put them on the pad and the leg, and you touch the leg and the pad, and you just count to 3 and put the solder in, and the solder fills up the pad right away. And they're very accurate. The point, you can be right at the point, or you can generate a lot of heat if you want for something larger. For smaller soldering, you have to use a round soldering tip with a bevel, maybe, or even a round tip without a bevel, a pointy tip. So I'm inspecting some of my soldering joints, and there's one I don't like, because when I snipped it with the wire snippers, it flattened out the solder. So I'm just going to touch that up. Now I'm actually going to do this by watching the tablet on the left, and you'll see my glasses looking at the tablet on the left. And as I approach the soldering iron, I'm looking at the tablet, and I'm able to zoom in and just tap it, and perfect. So that's good. So I'm trying to get used to using the microscope to do work, so when I do some SMD work, I'll be able to look right at the microscope and not look at the work so much. So here is a J5 clip, and I already have it in place, and I'm adjusting the focus, and I'm just going to do one edge, one pin on the end, and there's the knife edge, 1, 2, 3, and put the solder on. And then I'm going to pick it up and look at it and make sure it's flat. If it's not flat, I can hold it with my thumb and solder it at the same time. Although it's very hard to aim the soldering iron when you're holding one piece with your thumb up in the air, but it does work. So now I'm going to do the other end, and I think I've decided that the other end needs to be pressed down a little bit, but I think I'm going to do them all in a row. I don't know, let me think. Touch, 1, 2, 3, put the solder on, a little more, an extra 2 seconds. You can really hold the soldering iron on there for about 5 seconds without ruining the part usually. So now I'm checking to see that it's flat on the board. Okay, you want it to be flat. If it's not flat, you want to hold it with your thumb. But I'm satisfied it's flat, so I'm just going to do the other 3 legs. or pins, whatever you want to call them. Now I'm using mounting putty. I have big clumps of mounting putty that I use to hold the work in place. I don't use any fancy holder, although maybe at some point I'll get one. I must have done about like 30 or 40 or 50 of these kits, and you get the hang of it after a while, and you note some kits are better than other kits. Like development kits I don't really like so much because the pads are cheap. But this particular kit is really good. These are very quality pads, and you don't need flux or anything. So now I'm doing the other J5, and these two connect together. What you do is you break off that one that has a potentiometer on it, and that screws into the top of the base of the lamp, and then you have a connecting cable that connects the two together. That with the circuit board. So this one, I'm going to do one end. So you don't need the steadiest of hands to do this. You just need your hands to be steady at exactly the right moment. My kind of way of thinking is that if I can see what I'm doing well enough, I'm usually able to keep my hands steady just for that second, that split second to get the solder on there. And that holds with SMD joints too. So like I said in the other video, in part 1, this is part 2 of this build. In part 1, I did say, my motto is if I can see it, I can do it. I've done those 44-pin little tiny ICs, surface mount ICs, with a soldering iron. And if you use a little flux, you'll have no problem at all. So here I'm doing the other end. I'm doing the whole thing now. And you can see those are nice soldering joints. So here's the 104 capacitor, ceramic capacitor. There's 3 of them. I'm not going to show you all 3 of them. I'm just going to do one, and then I'll jump to soldering all 3 of them at once. But you'll see I put it in and bend the legs out. Some people don't like to bend the legs out. I like to bend the legs out. And it just makes it a little steadier. So this is the one on the left. And then you're not going to see the soldering iron do the other ones, but you'll see it do this one. 1, 2, 3, maybe a few seconds more. Doing the next one. Doing the next one. And you'll notice I do one leg on a component first when I have a couple of components. Then I'll come back and do the other leg so that you don't overheat the component. And also when you let the solder dry, it keeps the component from moving on the second joint of the second leg. So here you see me pointing out the notch on the 555 timer pad socket. I guess you call it a socket. And I've already put that in place, and I've got 2 solder joints. So I'm going to solder the rest of it. So I was kind of thinking, what is the purpose of these videos? I think I like to watch soldering videos. Some people like to watch them. Just watch people solder, maybe play music or listen to the guy talk. And but they're instructive. You learn things you didn't know. It's as if you soldered a lot more than you actually did by watching other people solder. Sort of like watching sports. And sports, as they say, is very good because it takes the place of wars between competing organizations. It eliminates a lot of violence in the world, sports. So sports is a very good thing. So here I'm doing the USB port. This is the one that gave me the most trouble but it's relatively easy. What I had trouble with is that there's two surface mount parts there, legs, and the way I had the component, the USB port on the PCB, it wasn't flat, so those were raised a little. So I had to resolder them, as you'll see in a minute, and push it down with my thumb. And then I went back and resoldered them again. So here you'll see I'm not having too much trouble soldering them as far as the size of them. And I've even done 5 or 6 of them on one USB port without too much problem, as long as you use flux. But you see my problem here. I'm trying to get it flat, so I'm holding it up, and that's not working. So what I'm finally going to do is pick it up and hold my thumb against it and solder them one more time. And it gets kind of hot. I'm holding my forefinger against it on my left hand. And it gets kind of hot, but not too bad. And now it's flat. There, now it's flat. So I'm going to do the other side, which is the mechanical pins, the legs that hold it in place. They don't connect to anything. So let's look under the microscope. All right, I'll turn it over. I'm content that it's flat. So now I'm going to do the mechanical pins. And these are very important. And you want to be careful with these sometimes, because if you put too much solder in there, it goes on the inside of the USB. And some of them, not all of them, but some of them have openings. And if it goes on the inside of the USB, you can't get the plug in. So then you're out of luck. Okay, so now I'm going to go back to the other side and try and clean up those two surface mount legs. And you're going to see me cheat here in a minute. All right, you can kind of see that's not real good lighting on that microscope, but you're going to kind of see that the solder is a little rough around those legs, and I really want to be sure it's in there good and solid, and have a good connection. So there I'm cheating. I'm using a little flux. That's no clean flux, so that works very well. And then just touch the soldering iron to each joint, and you're done. And now I'm going to look at it under the microscope. And there, they look much better. Not perfect, but much better. So that V1 and V2 that you see there, V1 and V0, I mean, if you were going to set this up without the battery, so it just runs from the USB power, you would short those together. But since I'm going to use the battery, there's a separate PCB board that they give you already built with all surface mount components. And that PCB board will fit right into those 3 holes there. Now you see me testing out the USB and also breaking it in a little bit, because it's kind of tight at first. So what you want to do is hold it carefully with your fingers so it doesn't come loose or break off, and then put the plug right in and take it out a couple of times. At least that's my system. So here is the PCB for the battery charger, And this is one trick, is to put the header pins on a breadboard and then lay the PCB on top of the header pins, and then you can solder it very easily and they'll be straight. And I did this also with the 555 timer. They give you the 555 timer chip. It's a surface mount chip, and they put it on a breakout board. So you have to solder the 8 pins to the breakout board. So I did exactly what I'm doing here, only with the 8 pins. So I'm not quite happy that this was straight, but it's good enough to work. And this is an excellent kit. I had really very little trouble with this kit. And it's useful too, because when you have a finished product, it's a nice desk lamp that I intend to use on my desk, because I don't like bright light on my desk. I like just enough light to see the keyboard. And if I need to write, then I make the light brighter. But there's very little distance between the end of my desk and the computer monitor. So now you see me soldering. This is the potentiometer. There's two pins there that you can't see. So I broke off that piece. That's what you're supposed to do. It's scored. It has tiny holes drilled in it so that you can break it right off. And they suggest you do the soldering before you break it off, so it's much easier to hold in place. Now it's a matter of attaching the battery charging circuit to the PCB, the main PCB. And this, I'd like this to be perfectly straight, but it isn't perfectly straight. So now I'm doing the mechanical assembly. I already built the lamp in part 1. So in part 2, I'm doing all this that you've seen so far. And now it's a matter of soldering the 2 leads from the LEDs onto that PCB, that circuit board. And I put them in coming from the top, going down. Also, I'm putting in the 555 timer into the socket. Again, observing the notch. So if it's in the wrong direction, it's not going to work, obviously. You see I already have the wires soldered. So now I'm trying to get it all in place, seeing how it fits. And it all seems to work out good. So the next thing I did was to plug in the cable connecting the potentiometer and the circuit board. So now I'm trying out the lamp, and you can see it's working nicely. So now it's a matter of mechanically putting the bottom on the lamp, which is not so easy to do. But I got it all in there, and I put it on, get the first screw in, and then it's pretty easy. Those screws are self-tapping screws, so you don't want to over-tighten them. So here I am tightening the screws, and there's the finished product. And let's see, turn it on, turn it off, turn the big light on, turn it on and off again. And there you can see the OTG cable connector for the pluggable digital microscope at the bottom of the screen.